Hello everyone. Hope you guys in a good condition to see my presentation. Let, let me introduce myself. My name is Ariya Chandra Pindika. My student number is 1930061116. Today, I'm going to explain my assignment from Bang Cristo to solve the system of simultaneous linear equation by using OPENMODELICA. I'm doing this assignment with Amira Salsabila and Alansyah Putra Dewantara. There's the outline of my presentation. First, we're gonna talk about linear algebra, which has a basic knowledge to solve this problem. There are two methods in linear algebra, direct method and indirect method. To solve this problem, we need Gauss-Jordan, which has an application of direct method. In the end, I'm gonna show you the step that I use to solve this problem by using OPENMODELICA. Linear algebra. Linear algebra is a system of equations can be represented as a product of matrices or as an augmented matrix. Ax equals to b. There are also special types of square matrices with unique properties. For the example of the linear algebra, you can see by the picture in this slide. So, what is in the direct method? In direct method, consideration will be on Cramer's rules, Gaussian elimination, and lower upper triangular matrices decomposition. It aims to solve the problem with an exact solution. When we use it, you can only use direct method in finite linear equation. What is the advantage by using direct method? Direct methods are good for dense system of small to moderate size. What is the application of the direct method? Like Cramer's rule, Gauss elimination, and Gauss-Jordan. Next, we were gonna talk about indirect method. Indirect method, also known as iterative method, requires only lesser computational effort. It is very much acceptable if the iterative method gives approximate solution with unconvergence criterion, whereas normally direct method would give a very accurate answer, because iterative are more favored when the metric is very big and sparse. When we use it, the indirect method, when very large matrices are there since they reduce the run of problems. What is the advantage by using indirect method? We can consider round of error to occur only during the last iteration. What is the application of indirect method? Gauss-Seidel method, Jacobi method. The Gauss-Jordan. Gauss-Jordan is used to solve this problem as a basic of the coding in OPENMODELICA. Gauss-Jordan is an algorithm that can be used to solve system of linear equation and to find the inverse of any invertible matrix. Next, we're gonna talk about the problem. The problem is the member of the truss shown in the accompanying figure have a cross-sectional area of 20 square centimeter and are made of aluminum alloy which have a modulus of elasticity 70 GPa. Using hand calculation, determine the deflection of each joint, the stress in each member, and the reaction force, and then verify your result. You can see the truss in this picture. So we need to defining the parameters. In truss number 2 and 3, we have to find the length of the truss by using the Pythagoras. So we need to defining the parameters, which one have a element, the which each element have two nodes, nodes I and nodes J. As you can see, element 1 have node I1 and node J2, element 2 have node I2 and element J3, element 3 have a node I3 and element J4, and node element 4 have node I4 and node J2. The area is 20 square of 7 centimeters. The modulus of elasticity is 70 GPa. The forces is 10,000 Newton and fixed support at element 1 and 3. And then we're gonna solve in the OPENMODELICA. First, we need to discretizing the problem into nodes and elements like in this picture. And the second, we have to input the parameter in this matrix. This matrix have an element, node I, node J, theta, area, modulus, and length. And the second matrix, we have to input the external load and the boundary condition for each node, like node fx, fy, ux, and uy. Like in this picture, I'm input from the problem to the coding like this. And then step 2 is assuming a solution that approximates the behavior of an element by using the formula. Stiffness, also known as K, equals to area multiplying by modulus of elasticity and divided by the length. As you can see in this picture, there is a stiffness matrix element. Next, I'm going to developing the equation for the element, the matrix element, like in this picture. Okay, next. After that, we need to converting the stiffness into the global format to make an more easy. Next, assembling the elements into the final form. From the stiffness matrix global, we need to change into the stiffness final. So the OPENMODELICA can simulate it properly. Next, we need to apply the boundary conditions and loads in the function of this displacement matrix. This step is used to find the displacement matrix. And next, we need to solving a system of algebraic equations simultaneously by using Gauss-Jordan. It's quite long. Like we need to input the integer, pivot column, pivot row, like this in this picture. And then after this Gauss-Jordan was end, it's all of the pre-post processing phase. And now we're gonna continue to post-processing phase. First, we need to finding the reaction forces like in this coding. Then we need to finding the internal forces and the normal stress by using this coding. And the last coding. The result that we have from the OPENMODELICA is the graphic of the displacement like you can see in this picture. U means displacement. And then we have a reaction, the graphic of reaction forces or R, as you can see. Then we have a result of the graphic K, or or also known as stiffness of the truss. As you can see, the graphic is like that. And then we have the result of internal forces and normal stress. There are two lines of the internal forces and normal stresses. For more variables, you can see in this picture. For more internal variable forces and normal stress. Okay, that's all from me. If I make a mistake, please forgive me. And if you have an advice for me, just comment on the below of the post. Thank you everyone for the attention. See you.